Hi everybody, it's Mrs. Mancuso, going to do a little chemistry regents review. Today's topic is equilibrium. So if you have a reaction and it is at equilibrium, it can go both in the forward direction and the reverse direction, and my rates of my reaction must be equal. So let's come up with an example. N2 and H2, these are both gases. You could combine nitrogen gas and hydrogen gas and make ammonia, NH3, which is also a gas. And so to balance this reaction, I could have 2 of these, which would make me have 3 of these. So 1 mole of nitrogen plus 3 moles of hydrogen make 2 moles of ammonia. So now I have a balanced reaction. If it is at equilibrium, my rates are equal and my concentrations are constant. So let's talk about that for a minute. Concentrations constant. Okay, what that means is the amount of nitrogen and the amount of hydrogen are not equal. So I cannot say my concentrations are equal, but they are staying constant, meaning I constantly need 1 mole of these for every 3 moles of this in order to make 2 moles of this product. So that's what I mean by constant. All right, and rates equal means that I'm doing as much of the forward reaction as I'm doing of the reverse reaction. There are 3 ways to throw off equilibrium, and they are to change pressure, temperature, and volume. So if I change the pressure, the temperature, or the volume, I will change equilibrium. Pressure only affects gases, and temperature and volume are going to affect everything. So, and I can affect concentration. All right, so volume is affected by pressure or if I change the size of the container that I'm in. All right, so I'm going to take this reaction again. Actually, this time I'm going to write it out this way so I can have it a little bit longer. N2 plus 3 H2s makes NH3. And first I'm going to do concentration. So when doing concentration, wherever you add, it will shift away, and wherever you take, it will shift towards. So I'm going to add, let's say we added nitrogen. So I show it with little dots right here. If I add nitrogen, my equilibrium is going to shift to the right here. That means I'm going to be making more of this, so this value will go up, and both of these values will go down. So I highly suggest doing the dots and the arrows to figure out exactly what's happening. It will do this shift until it's back to equilibrium. So once you've made enough ammonia and you've used up these, because these have collided with each other, you'll be back to equilibrium. All right, another example is what if I took away? So if I take away nitrogen, I put an X here instead. Wherever I take away, I need to move towards. So this time my equilibrium is going to shift to the left. That means these will increase, so this arrow is going to go up, and this is going to be used up, so this arrow is going to go down. So that's how you do add away, and that's how you do take towards. And the last one is pressure. So if I increase the pressure, I will decrease the volume. And again, this is only for gases. So if I increase the pressure, I'm going to have less space available. If there's less space, I want to favor the reaction that makes less moles. So I have to count up the moles of gas. Here's a gas, here's a gas, and here's a gas. So actually all of the reactants and the products are gases. So I count them up. There's 1 mole here and 3 moles here, so I have 4 moles of gas on this side, and on this side I only have 2. If I have less room, I'm going to favor the reaction that makes less moles, so I would favor the forward reaction, which will make my NH3 increase in concentration, and it will make my N2 and my H2 decrease in concentration. All right, the next factor I want to talk about is temperature. And in order to do temperature, I need to know the heat of the reaction, the delta H. So I grab my reference table and I go find the reaction. So here it is. N2 and H2 makes NH3s, and it's a negative 91.8. So negative 91.8 means that it's an exothermic reaction. And exothermic reaction means this is a product. So now when I write my reaction, N2 plus 3 H2s, 2 NH3, I want to add 91.8 kilojoules on the product side, okay? So if I increase temperature, it's the same thing as adding heat. So I find where the heat is, I add it, that will shift my equilibrium to the left, that will make my reactants over here, N2 and H2, go up, and it will make NH3 and the temperature go down. So I will be back to equilibrium if I follow these rules. Le Chatelier's principle is the discussion of adding a stress to equilibrium and figuring out what happens accordingly. So if they say in terms of Le Chatelier's principle in your question, then you have to talk about which direction you would shift and what would increase and what would decrease to get back to equilibrium due to that. Thanks for joining me.